Hello everyone, welcome to 1045 Engineering. We are here with yet another video in our Grind 75, a Better Blind 75 coding series. Today we are at our 16th problem out of 75, climbing stairs. We have to figure out total number of ways that we can climb stairs based on the number of stairs. Okay, let's jump into the problem and start solving. Last time in our series we have already solved in some note. Let's start with climbing stairs. Okay, so let's go through the problem statement. You are climbing a staircase. It takes n steps to reach the top. Each time you can either climb 1 or 2 steps. In how many distinct ways can you climb to the top? Okay, so problem is pretty straightforward. We have to complete the staircase and we have to figure out what are the different possibilities. We can either climb one step at a time or 2 steps at a time. Okay, for example, if total number of stairs are 2, we can go 1 step plus 1 step. Similarly, if total number of steps are 3, we can go 1 plus 1 plus 1 or 1 plus 2 or 2 plus 1. Okay, now there are different approaches to solve this. If you have a better one, please comment in the comment section. But think of it like this. Think of the simplest approach and yet the fastest one. Okay, we need to find a pattern. Okay, let's say n is equal to 3. Okay, for n is equal to 3, before touching the third step, let's create 3 staircases for this. So first staircase, second step and third step. So we have to reach at this step. Imagine before reaching the third step we were at second step. Okay, so we can take only 1 step forward and we'll reach the third one. If earlier we were at 1 step, so we'll take 2 steps forward and we'll reach the third step. For let's say if total number of steps n is equal to 1, we can only take 1 step. So solution for n equal to 1 would be 1. What if n equal to 0? Then 0. N equal to 2, solution is 2. N equal to 3, solution is 3. The pattern is, let's see what is going to be the solution for n equal to 4. Okay, for n equal to 4, different possibilities are, we can go 1 plus 1 plus 1 plus 1, right? Or we can go 1 plus 2 plus 1, or we can go 2 plus 2. Similarly, we can have 2 plus 1 plus 1, and finally 1 plus 1 plus 2. So if you see, total number of steps are 1, 2, total different possibilities are 1, 2, 3, 4, 5. In 5 different ways we can do it. Now, before touching the fourth step, we can find out how much total number of attempts it takes to reach second step and how much total number of attempts it takes to reach third step. Because from third step we can take 1 step and reach fourth step. From second step we can take 2 steps and reach fourth steps. If you see, this answer for n equal to 2 is 2. Okay, so answer for n equal to 2 is 2. Answer for n equal to 3 is 3. Answer for n equal to 4 is 5. Similarly, if you go down, n equal to 1 has the answer 1, and n equal to 0 has the answer 0. If we start from third, we can see the solution for 3 is the summation of last 2 steps, n minus 1 and n minus 2. 1 plus 2 is equal to 3. Then for n equal to 4, 2 plus 3 is equal to 5. Right? Similarly, if you will check for n equal to 5, the solution will come out to be 8, which is summation of 3 plus 5. So simply we have figured out a pattern and we can use the same pattern to actually solve our problem. This is actually a problem from dynamic programming. We can use brute force attacks and check one by one multiple attempts and reach the solution, or we can check, or we can solve it using dynamic programming. Here we compute we find a pattern, we compute the initial steps, and based on the earlier answers we calculate the next one. Okay, let's comment this piece of code and let's start solving. So first we need a base condition. We have seen for n equal to 0 answer is 0, for n equal to 1 answer is 1, n equal to 2 answer is 2. Okay, so we'll say if n is less than 3, I can actually take less than 3. There are n ways to climb the stairs, right? Stairs. So we can simply say if n is less than 3, return n, right? Similarly, now we'll create an array that will store the solution of all the previous values. Okay, for n equal to 0 it will store the solution, for n equal to 1 it will store the solution, and from that one we can ask for the previous two solutions. Okay, let's create one array. Create an array to store the number of distinct ways for each step up to n. Okay, so we'll create int. Now this is a problem from dynamic programming, and for everyone to understand that we are doing it in dynamic programming, we'll name the array dp, dynamic programming. New int n plus 1. Why n plus 1? Because we are also considering n equal to 0. N is from 1 to n, and then we wish to consider n equal to 0 as well, so we need extra space. Okay, now since we are already aware of the initial answers, we'll simply initialize them, right? Initialize base cases for n equal to 0, 1, 2. Okay, so we'll say dp of 0 is equal to 0, dp of 1 is equal to 1, dp of 2 is equal to 2, right? Now we can simply fill the array based on the total number of steps there are. So total number of steps are there in the staircase. So we'll say fill the dp array for steps starting from 3 to n. So we'll say for int I equals 3, I is less than, we have to take equal to as well, then equal to n, I plus plus. We'll simply say, now we are already aware that the solution of one step is a summation of previous two steps, right? I'll just comment it for everyone. The number of ways to reach ith step is the sum of ways to reach the previous two steps. Okay, then we get the dp of I is equal to dp of I minus 1 plus dp of I minus 2. I minus 2. 2. Okay, right? We are done here, and then in the end we can just return the last one, because n is going to be in the end, so we'll just return the last number from the array. So we can say the result is stored in dp of n, which contains the number of distinct ways to reach the top. Okay, so we can simply say return dp of n. Okay, I hope this problem was pretty clear to everyone. Still, if it creates doubt for yourself, then please let me know in the comment section. I'll be happy to give you another solution to solve the same problem. It wouldn't be as efficient as this one because here we are solving the problem in O of 1, plus we are already using the computations pre-calculated. So these values are already calculated. Every time we go for n equal to 3, n equal to 4, n equal to 5, we are just simply adding the previous 2 steps answers, like a Fibonacci series. Okay, let's run it. Okay, let's submit and check. Okay, it's raining outside, so it's internet is slow a little. Yeah, beats 100% of the users because yes, with DP we are using the best time complexity approach. Okay, that's all from today's video in 1045 engineering. If you like the video, please like, share and subscribe. If you have any comments to improve the video, please let me know in the comment section. Thank you everyone.